Welcome to Advanced Data Types. So, how many of you are using Postgres? It's 2 out of 3. My name is Andreas. I work for a company called Adjust in Berlin. I'm also board of directors for Postgres Europe. So we founded Postgres Europe many years ago. We run conferences all over Europe, like PostMPG Day, like Postgres Conference Germany last week, and Postgres Conference Europe in October in Berlin. And at Adjust, I'm heading the database team, and we have roughly 1,000 databases, Postgres databases running, everything from very small up to like 30 terabyte dish, 250,000 tables dish, this kind of stuff. It's challenging. I will upload these slides from my talk, so if you just look up my name, you will most likely end up on my blog. On the right side, there's a link to my writings, and I upload there all talks I have, all these slides from my talks. You can also find me on Twitter or on LinkedIn, or, as I said, my blog. At Adjust, as I said, we have a couple of challenges for databases, but also our other teams, so we are hiring. If you're interested in a challenging job, join us. Okay, any one of you have seen my previous talk? There's another talk called Data Types in Postgres. It's more on a basic level. This talk here is more on an advanced level. Let's skip this. Out of the material I have for advanced data types, I can maybe do a full day training. So this is just skimming over what we have, just giving you some examples how extendable Postgres is. What you can do, you can write your own data types, you can use the many data types out there. But here in this talk, I want to go a little bit into details what you can do instead of just listing more data types we have in Postgres. If you look at Postgres, every data type you have, even the basic ones like integer and text and so on, these are in theory all extensions to Postgres. Yes, they come by default, they're installed by default, but it's just another data type. Which means Postgres is very extensible, to the point some people can't even believe. Just to give you some examples, I like to have fun with playing around, and someone throws a challenge on maybe Twitter or social media, and I try to take it a little bit further. I have an example here. Everything up to table name, column name, content, database name is a star. Yes, you can do this in Postgres. So I have a schema name as a star, I have a data type as a star, which just includes stars. I have a table name, just a star. My data is just stars, I'm just selecting from stars. Yes, one can have fun. Another example, everything is just space. I have a space as database name, as a user, as table name, even as content. Yes, you can put Postgres that far. It's just empty. Nothing in there. Another challenge, Christoph last year put out a challenge. Well, can you make Zoe not being Zoe? Well, yes, you can. I went ahead and created a data type which actually does not compare with each other. So I made it unequal. And if you try to do unequal here, then it says, okay, but they are equal. And the other way around. If you try to compare column A and B, they are not equal, even though they have the same content. In this blog post, I describe how this is done. Or you can just overload functions in Postgres. I mean, anyone knows now. You can just make something totally different in Postgres, overloading a function and just returning something else. Okay, all of this is fun. One can play around, one can see how extendable Postgres is. Let's go into the details here. I will show you what arrays are. A very hot topic we have in, I think, almost every database these days is JSON. And Postgres has a very nice JSON functionality. We look into composite types, we look into domains, how you can use them, into ENUM and range types, and at the end, a quick example, how you can create your own data type in Postgres. Because yes, you can do this. One of the challenges we have in Postgres is a data type called money. What is it good for? Any idea? Well, don't use it. Yes, it's there for historic reasons. There are a couple users. Every time someone pops up on a mailing list and asks, how can I store any type of money type in Postgres? Well, one response is always money, but there are a couple of problems with this type. It can only hold one currency, database-wide. So you cannot store like euro and dollar in one table. That's not how it works with money type. You can only define one currency on a database level. You cannot use it for any kind of like exchange rates. You want to store what's today's exchange rate between yen and dollar. Doesn't work. This decimal separator you have is different for every country. So if you use dollars and euros, they have different decimal separators. If you define them wrong, you get different values in your database. Under the hood, money is just like a numeric data type. So every time someone tells you to use money, just use numeric. Just to give you an example how wrong this can go, that's a comma separator for decimal for euro. So this is 123 euro, 45 cents. If I try the same with a different operator here, I get 12,000 euro. It all depends what your system setting is. You as a user, you don't really know. That's a DBA job to set. Easy to screw up your data. You export one data from one database, the next database you import your data has a different setting, and you get totally different values. Not what you want. Yep. Yes, the default currency is incurred from LC monetary. It's a system-wide setting, yeah. No, it's not. There's no mapping. Okay. Conclusion, don't use it. Just to give you an example, so in Europe, in most of European countries, we use a comma as a decimal separator, except UK because, well, UK. US, you have a decimal point here, except some certain parts of Canada, of course. So if you try to export dollar here into Europe, into euro in Europe somewhere, you get totally different values. Don't do it. Let's move on to something more reliable, arrays. Of course, you can have like integers in a table and store one value in every row. What Postgres can do, you can store multiple tuples, multiple values in one array in Postgres. It's called array. It's a built-in type. Any built-in type can be an array. You can specify a dimension, like I want to have 5 values, but in the end, Postgres is just ignoring what you say here. You can also extend it later. Arrays were very, very often used before JSON came around. So since a couple of years, everyone is moving to JSON, but you will see it in other applications. So here I define a text field as an array. So I just add the brackets here. I can use an array constructor or curly braces. Both ways work. You can create an array and just insert 2 values or multiple values into my database into one single field. Then of course I can select the entire field. If I just select the field, I get my entire array back, so in curly braces here. But I can also go and just select one value. like in every programming languages where you have arrays, you can just select one value. It starts at 1, not at 0. So first value in my array is at position 1. I can, of course, also search in my array, so I can find out if a specific phone number is in my array. So I can use it as an address book and then try to look up something. I can also define multiple dimensions here, so arrays in arrays, stacked at different sizes. Find out what my array dimensions are. And of course I can also just go and select one single element at any given position or multiple elements from my big array I have. Sorry. I can find out what are my array lengths. So we have plenty of support functions for arrays because, well, it was really used for a very long time in databases or in Postgres. And I can find out if one specific element is in my array. So if I want to see, okay, DEF is on position 2, then yes, I get a 2 back. Otherwise it's false, or I can just use any to search in any field. I can, of course, modify arrays, so I can say array prepend, just move something at the beginning, or array append, just add something at the end. If you actually want to move something into the array, you have to split it up and combine it again. It's a bit more complicated, but you can do it. You can transform arrays into strings. So you have array to string operator. You have to specify what kind of element you want to have as a fill element. And you can, which is more useful, actually unnest an array and make it look like a table. So you have one big array in one field, and then if you select it and unnest it, then it gets returned as a list of values, like any other table. Any questions for arrays so far? Now we get the very same functionality in JSON. In Postgres we have two different JSON types. One is called JSON, one is called JSONB. If in doubt, anytime use JSONB. It's a newer one. The difference is the JSON type stores the data as you put it into the field. There's no parsing. The parsing only happens when you try to read the data. At this point, the database might figure out, oh, whatever you put in there, it's not valid JSON, it raises an error. JSONB does parse the data when you put it into the field, and it does not store what you write into it. It actually stores exact JSON value as an indexed value in your field. You can use all kinds of functions we have in Postgres for manipulating JSON, searching in JSON, extracting data from JSON. I'll give you a couple examples here. So now I'm going over the same example. I have an address book. Now I'm not using arrays, now I'm using JSON here. I have a JSONB field here. I insert something as an array, and you see I get my JSON array back. This is still a JSON object. So I have a text number, but it's a text in JSON. That's why we have the quotes here. And of course I can cast this element to text in Postgres. Then I get a Postgres text back, not a JSON text. That's most likely what you want to do in an application, because many applications don't really know what a JSON object in Postgres is and cannot work with it. So if you transform it on the fly to text in Postgres, that's something many applications know. That's easier to handle. What we can also do with JSON, we can just try to store everything in one JSON object. So doesn't matter, names, birth dates, address, we just have one JSON field, like NoSQL databases. So I have one data field here, JSONB. Now I'm adding something. That's my name, it's Slonik, this guy over here. I have a birth date. This is just a string. If this would be a date field in Postgres, Postgres would actually verify the date if it's valid. Since it's only a JSON object, Postgres doesn't know it's a date. It just stores a text string. But when I select it, I can cast it to date, and at this point, Postgres will try to verify the data in my JSON field, cast it to date, and figure out, okay, this is a valid date or not. So we see we had this 97 here. Yeah, what is it? That's April 3rd. Yeah. So what happened here? One of the common problems we have in NoSQL databases. We have two fields with a similar name but not an equal name. Happens quite often because you don't have any kind of verification. So we can actually use this and just change it. So we have only one field which is an uppercase birth date here. The other one is lowercase. What we can do, we can use JSON operators we have. So we want to update this table, update the data, replace or remove the uppercase field, build a new object with the content of the uppercase field, but rename it lowercase, where the data is actually uppercase birth date. So we're building on the fly a new object with the entire content, except the wrong field, but we update the wrong field with the content of the old field. All in one query. And of course, we end up having two fields with the same name now. It's quite powerful what we can do with JSON in Postgres. So another example, as mentioned before, we can do this on-the-fly conversation between two dates in Postgres. And I can, of course, use this to do any kind of date queries in Postgres. So what I want to do here, give me all fields where the birth date casted to a date is older than 18 years. Whatever the date is, whatever the current date is, I'm looking for anything older than old years. And I only get one entry back because the second one was 2000 something. I can also add new fields like I did in my array example. So I'm again using a JSON build object. I add a new field called hobby databases, and I add this using the concat operator to my existing field. And we end up having new entries in our data here. So we see we have a new field, hobby databases. I need to look nice for a picture. Okay, again, this is a JSON text. You see we have single quotes from Postgres to make it a single field. And in our single text field, we have a JSON text which is quoted in double quotes. Sorry. I can also update the field, again using JSON B set. So I'm specifying what field name do I want to update. And then my contact, again, it has to be JSON text. That's why we have two quotes here. And then if we look at the result, you see we updated from hobby databases to hobby PostgreSQL. So any kind of text manipulation, content manipulation you want to do in Postgres in JSON objects, you can do these days. There are plenty of operators. This really only gives you an overview of what we can do because there are so many operators and possibilities. I haven't seen any use case you can do in databases like MongoDB which you can't do in Postgres. Any questions about JSON? Let's move on. So we have composite types in Postgres. It's called a row type or a record. Every table you have in Postgres has a record type in a database. And the record type looks exactly like the table with all the columns we have. This is very powerful because every time you do something like return table, you know exactly what the structure of your return set would look like. You can use record types everywhere where you can use a simple data type. However, you cannot use any constraints, like foreign keys, like null, not null, like check, and so on. So we have one example here, so create type. We create a currency value type because we had this money type before, and I want to show you that we can do better. So we have a currency here, source currency and a destination currency. Of course, we want to have a date from when this currency conversion rate is, and we want to have a value. What is the conversion rate? It's numeric. 10 digits should be enough for most currencies in the world here. And then you can use this new value we have, or this new type we have, like any other data type in Postgres. If you would build this table, not using a data type, you would have to add all 4 columns here and add checks, etc., etc. Here we're just using one value. And then if you want to insert data into it, you're using a row operator. I want to convert from euro to US dollar for this date. This is my currency conversion rate. Because we always need these 4 values together, it makes sense to move them into one operator or one type in Postgres, so we have everything together in one row. Again, if we select this, then we get rows back, or row setbacks. And you can use the dot operator here and specify, okay, which value do I want to have out of this row set. Now we come into domains, which are very similar to the previous types we had. The difference is you can add any kind of, yes please?
For composite types, do people try to just implement their entire schema with composite types, or what are the limitations?
Can you create your entire schema with composite types? Yes, you could in theory, but it only makes sense if you have tightly coupled values. Like in this case, currency conversion rates, you always have 4 values. Makes sense to move them together into one type. You cannot add constraints to composite types. You can add constraints to domains. Let me show you an example. The domains look like a composite type, but you can add constraints. It's actually a feature from a SQL standard, so any database should support it. You can have default values, you can have check constraints. It's kind of underrated because not many people are using it. However, there are also some fallbacks, because if you want to drop something from a domain, it will just drop the data in your table. So you really need to be aware of some pitfalls here. Otherwise, it's a nice feature. Just some use cases. You can use integrity checks like check constraints. You can verify that specific units are there, like if you want to add a speed field as a text field, and you can verify, okay, whatever the user added is actually has a unit. Or if you use coordinates, you can verify, okay, this is actually very valid as an ID. Yes, you can do all of this on a table level. Like if I want to add coordinates, I can just add a coordinate column to my table, but then I don't have the additional checks on it. If I add the checks to the domain type and use the domain type in my table on multiple places, I have these checks applied to every place where I use the type. I don't have to repeat all the checks on my tables. Okay, let's go for a check. I want to store an MD5 sum in my table. What can I do? I can first of all check, okay, something needs to be inserted, so I make this type not null. I cannot insert a null value here. And MD5 checksums are 32 characters long, so I actually check that the length of the value is 32 characters. So I cannot insert anything which is not 32 characters. I could expand this a little bit more. I could also check that I only insert valid text characters, but beyond this example. And then again, I can use this new type like any other type in Postgres. And if I try to insert something which is not a valid MD5 checksum, you see Postgres just rejects my insert here. I cannot do that. Of course, if I insert a valid MD5 checksum, it goes through. It's a very basic example. We can do a couple more things. So we can set not null, which is important. We can add more constraints to it. I give you a couple examples. We can also change owner and rename and set schema. All the valid things we can do. Enumeration types. An enum, like in any programming language, is a type where you can add specific values to a list. And then you can only pick values from this list which are specified in the enum. In a database, this replaces a lookup table. But if your values in your enum are changing more often or quite often, then you should really consider a lookup table. So you can just use insert, update, delete to change the lookup values. If your values are not changing, then yes, use an enum. You can also use a domain for the very same example. Like you can have a check constraint with an in field in your domain and just make sure that all the values are valid. One of the nice use cases I have for this is a domain type can actually do case-insensitive checks where the text in an enum field is always case-sensitive. I'll show you an example. So I have two types here. One is called traffic light as an enum. So I have red, yellow, green. And I have a domain type as text, not null. So I can actually verify here in my domain type already that there's a value. And I have a check, lower value in red, yellow, green. So it doesn't matter if a user uses uppercase red or lowercase red or whatsoever, I can verify the lower value. I'm going to use this in a table. I have my enum type here, and now I have to do the not null here, because enum doesn't allow me to check not null before. In my domain type, it's already checked. Now, if I want to insert lowercase values, of course it's working because both of them are lowercase. If I want to insert something with uppercase into the enum, it's not working because it's not a valid type in my enum. If I turn this around and use an uppercase red here for my domain type, the domain type always checks for the lowercase value. So I made my check constraint here more flexible. And of course it's working. Okay. A bit more advanced example. So you want to maybe check if someone is alive. What is your check for this? Well, given today's date, I want to make sure that this happens in my example here, 150 years. But this check also works in 50 years from now. So I create a domain, I add a check constraint, and I add this as a range, so I have a date range object here, which has two values, a start value and an end value, a start date and an end date. The start date can be not infinite, and the end date can either be infinite, so the person is still alive, because we don't have an end date set, or the end date set is lower than 150 years from now, right now. So if I use this in my database as an example, I set an upper date 2021, and I don't set an end date, so of course this person is alive. This check is working. Now I try something 2021 and 1900 as death date. Doesn't work because the end date is lower than the birth date. So we're checking this, it's not working. We can go from 1900 as a birth date to 2021. That's still in our 150-year range. And if I exceeded 1800 to 2021, you see it's failing because now it's more than 150 years. So we have a very complex check here built into this domain type, which makes sure that all the constraints we define on this data are actually validated. So if you have to repeat this on multiple types and multiple places in your database, and you have to update this code at some point, then it's very complicated to get all of this updated, or you have one central domain type which can do all of this for you. Okay, of course you can also change an enum, so you can add more values, you can rename values. It's all working. You can drop values from an enum, but you can only drop values if they are not used in a table. Questions, composite types, enums, domain types. It's just simple examples here. Well, a bit advanced, but anyway. Many more ways you can use them. Range types. I already used the range type before for the 150 years. So it's always a range of things. It can be a range of dates, it can be a time range, it can be a range of lists like integers, it can be the numeric range. We're using this in Postgres also for partitioning, so you can have range partitions, like for every month one partition, or for customers from 1 to 1000 one partition, 1001 to 2000 one partition, and so on. And of course you can create your own range types. What I'm doing here, I create one range type as a floating point number, and I specify which function I have in Postgres which can calculate the difference between this range. I will use it right now in a moment. So I can insert some values here. And now if I want to use this type in my table, and because I specified which function can do the calculation of the difference, Postgres is actually able to create an index on my column because it knows how to figure out which value is bigger or larger and which value is smaller. It's literally all it needs. If I specify this, it gives Postgres the ability to index my column, my data type. So I insert some values here. You see it's 1, 3, and 2. Different sort order. And I can do my order by range 8 here. And you see I get them sorted back. And I can actually verify that it's using my index scan. So I forbid sequential scans here. I ask Postgres for this query, and my query plan says, okay, I'm using this index. Of course, that's just 3 values, that's very small. But if you have your own data type and you have a couple 100 million values in your table, you really want to have an index on it. Yes? Can you order by the endpoint? Yes, you can. You can also add constraints on range types. The most common one we have is exclude, but there are many more. I give you an example. I think the prime example you find everywhere is how you book a meeting room or how you book a hotel room and make sure that there's no double booking. We need an extension which is called b3gist to create a gist index. I have my room reservation table here. The stay is the date range, so someone wants to stay in a room from this date to this date. Couple days, 1 day, 1 night. The room number, of course. And then I can add my constraint here, exclude. If the room number is equal, there should be no overlap in the stay. So we exclude this too. Let's get some bookings in. So we have the first booking 2019, 11th of November to 13th of November for room number 42. And another booking for almost the same time, room number 23. There's no overlaps here because it's a different room, even though it's the same time. Now I'm trying to get a second booking into room number 42 with an overlapping time. And Postgres rejects it right away because we have overlapping time and the same room. This excludes each other. We cannot do this. In order to do this, we need to have an index, and that's why we need to have this B-tree gist extension here, sorry. Because otherwise, if we don't build this gist index here, this would be a full table scan every time we want to verify the values. Would take a very long time. There are many more constraint operators we have. So of course we used overlap here, we used exclude. We also have equal and not equal and less than and greater than. Basically everything you want to use in a table, you can use as a constraint on range types. Because you asked, yes, you can access the boundaries in range types. You can ask for the lower range here or for the upper boundary. You can also find out if one of the boundaries is infinite, so it's not defined. It gives you back a false because the lower boundary is defined, but the upper boundary is not defined, so it gives you back a true here for the upper infinity function. Questions about range types? And I come to my last example. As I mentioned initially, every data type in Postgres is basically just an extension to the database. You look into the system catalog tables, you find out how every data type is defined. Of course, all of them come predefined, but for Postgres, having them predefined is nothing else than any extension you add to the database which adds more data types, which means you can create your own type. One example we did a couple years ago is how does the native PHP Postgres driver handles Boolean types? Anyone knows? Well, it doesn't. The nice thing, everything for the native PHP driver is just text. This is before PDO came around, all the other drivers. So, I have some PG fetch row here. It returns me a row from my table. And this is very common in PHP if a Boolean value is true or false. Well, what happens if this Boolean value you get back, T or F, is just text? Which part of this equation is true every time? So you always run into this true part because the variable Boolean here is really only T or F. So there's always something in it because it's text, it's not a Boolean. So it's always true. So we had a problem importing an application from MySQL to Postgres, and we had a couple thousand of these functions. Do we want to change every single occurrence of this if construct? No. So we went into the database and we created our own extension. So we called it Boolean2. All we need for this to work is we need to have an input and an output function. So we basically need to tell Postgres how to get values into this type and how to represent the values. And the receive and the send function is there so that we can have the internal representation of the type. Lucky us, we had text already in there, and we wanted to have Boolean back, but a different Boolean type. So we don't have to write new functions, input-output functions. We just had to use different ones. So we have a Boolean in function. We're getting a C string in. Boolean in, that's our new data type name, Boolean2. We're using bool in, which is from the original Boolean. And Boolean out, which is the representation of the type, is no longer bool out, but is integer out. So we get an integer back, 0 or 1. That's basically all the magic we had to do to create a new type. Then we had to go with the existing other support functions, so there's a little bit more to do, but it's basically only copying what the original type does. Then we create a new type. We use the new Boolean type input and output function here. We have to specify the length and how it's stored internally. We add a command here. So at this point, we already have an existing function, an existing type we can use in our database. So all we had to do in the database was change the existing Boolean type to our new Boolean type. Done. The output we got, I'll show you in the end, was no longer T and F as a text string, but was 0 and 1. For PHP, it means, yes, it's true or it's false. We solved the problem in a couple hours instead of rewriting the entire code. We need a bit more here because we want to be able to actually compare values with our existing Boolean in Postgres and the new Boolean we have. So there's a bit more we have to do. Like we need to figure out how to tell Postgres which of the values is bigger and smaller. We need to create a couple operators here, so we need to have Boolean in and Boolean out. But I can just skip over this. It's a very long list of things where you just have to make sure that your new and your old type are actually in the right order. Need a little bit more for equal and not equal. About 20 function and operations later, we had an existing type with all the functionality we need. So now we're able to use this one in our table. Because we created all the support functions, we could actually create an index on it. And we can just insert regular Boolean values. True, false, 0, 1, TF, whatever Postgres accepts. And if we do a select from a table, we suddenly get back a 0 and a 1 instead of 2 of F. Problem solved. Wasn't that hard. Any questions? Yes, please. Can you speak a bit up, please? When it comes to cost, would I recommend creating this type? Well, this is about, I think, 15 years ago. We had a PHP application we had to port from MySQL to Postgres. We didn't have all the tools we have today for doing migrations and everything. And it was a relatively easy way. In a couple of hours, we fixed the problem, which would have cost us probably months to rewrite the code. Because back then, no application tests, no unit tests, no nothing. And we could be relatively sure that if we fix it this way, we catch every single place in PHP. So, yes, worth the effort. I would probably do it today. If you want to, I have some Postgres stickers up here. So there are black ones for Macs and white ones for real Lenovo laptops. Come and get one. Thank you. Yes, and if you go to my blog, just search for my name, you find my blog. On the right side, there's a link called Writings, and I will upload the slides there.